video. Assalamualaikum. My name is Iza Atira binti Ahmad Sifan.
My name is Nur Syafiah binti Waka. My student ID is 2019258982.
My name is Muhammad Syafiul Hamri bin Amran.
And we are from Group 7. In this video, we are going to conduct an experiment called Tensile test. So let's get started. Don't forget to switch off the machine after being used.
I will show you my result for this experiment. Table 3, Table 4, Table 5, and all the graph, force resist elongation, and also the graph for stress resist strain.
The result obtained from the graph and the experimental have a large difference from the reference value of each type of the properties. For example, the difference between the modulus of elasticity value and the reference value is over 90% of steel, aluminium, and brass. The discrepancies may be because of using the wrong grip. Slip edge will produce a high travel measurement if the grip is not able to secure the material properly. Next, it is maybe because of axial misalignment. These moments and offset can skew the measurement and distort the sample if the sample is misaligned.
Value from the result and the reference were different. This is because there could be an error occur during the experiment. Some of the value in the result are lesser than the value in the reference. One of the possible error occur during this experiment is not tighten the gripper tight enough and the specimen can be loose, that causing an inaccurate force applied. Other than that is misalign the specimen on the gripper, and this can damage the specimen because of the unequal forces acting on both of the end of the specimen.
So the answer is the reason there is difference between experimental value and actual value is because it might be exposed to external factors such as thermal expansion and machine's inaccuracy.
They all have a high level protection from corrosion. They are also malleable and can be deformed. Steel is the strongest, brass is the most conductive, and aluminium is the lightest.
These are the similarities and differences that I could find For steel, brass, and aluminium, the similarities are 3 of them has high hardness and also corrosion resistant. For the differences, steel has less malleable and elastic. For brass, has high malleable and elastic. For aluminium, has higher malleable and elastic.
The similarity of the tested materials are all materials the plasticity different. For the steel is relatively soft and weak but good toughness. Brass relatively soft and easily cold work. Aluminium high electrical and thermal conductivity.
Yield point is a point on a stress-strain curve that indicates the limit of elastic behavior and the beginning plastic behavior. Meanwhile, yield stress is the material property that defines the stress which the material begin to deform plastically. Yield strength is the most accurate indication, as yield strength is used to determine the allowable stress to which a material can be subjected.
Yield point is one of the points that can be found in stress-strain curve. Yield point is located when the strain increases more than the stress, and this is where the graph becomes nonlinear. While yield strength is defined as the stress when the sample starts to deform. The most precise way to indicate of a material's fitness is by finding the yield point, because it could identify the maximum of stress applied for a material before it deforms.
Yield point is the point on the graph at which the material undergoes yielding, which is where the material will begin to experience plastic deformation. Yield strength is the amount of stress needed to be applied onto the material for it to reach yield point. The yield point is more important in tensile application as it indicates the beginning of the plastic deformation.
Elastic limit is point which the material remains elastic, while proportional limit determines the greatest stress that is directly proportional to strength. Proportional limit is more important indicator as a transition point can be calculated by a specified percent change in slope. Steel is the highest, brass is higher, and aluminium is the lowest. Steel is the lowest, brass is lower, and aluminium is the highest.
Elastic limit is the maximum force that can be applied on the material before deformation could happen, while proportional limit is to determine the suitable stress and strain applied to the material to produce a linear stress-strain graph. Elastic limit is more important than proportional limit because elastic limit can help to determine the maximum stress strain that can be applied on the material.
Stress strain diagram make it easier to determine the result. From the stress strain diagram, many properties can be determined such as elastic modulus, yield point, and many more. Load elongation diagram also is the simplest way to predict stress strain behavior after dividing by the cross-sectional area.
One of the advantages for stress strain diagram is it helps us more on the mechanical properties of the material, such as the elastic limit, the ultimate strength, the breaking point, and others. With all of this information of the characteristic of the material, this can help the design engineering to understand more on the strength and the weaknesses of the material.
In conclusion, to obtain a general understanding of how different materials and cross-section area behave under unagile tensile loading is achieved. There are 3 types of materials used in this experiment, such as steel, brass, and aluminium. All of them obtain different graphs and results. From the result, we can determine the relationship between stress and strain, the comparison between the mechanical properties of various materials such as fracture stress, modulus of elasticity, yield stress, ultimate stress, cross-section, and the utility is also accomplished. Therefore, the experiment is successfully done.
Overall, this tensile test experiment was to obtain a general understanding of how different materials and cross-section behave under unaxial tensile loading, determine the stress-strain relationship and compare mechanical properties of various materials and cross-section. Lastly is to obtain the mechanical properties, for instance, the modulus of electricity, the yield stress, the ultimate stress, the fracture stress, and the ductility ratio. All the objectives above were achieved. Firstly was got to recognize the different type of materials and the cross-section act when the materials are under unaxial tensile loading. Secondly was that every material stress and strain diagram can help to understand and make a comparison between the mechanical properties on each material. Lastly was to know all the mechanical properties of the material can be obtained from this experiment.